The concepts of domain and range are very important as we study the inverses of trig functions. We must apply restrictions to the domain and range of the trig functions in order to make them one-to-one functions. Let's look at an example to show how to restrict the domain and range of a function in order to make it a one-to-one function. Notice that in this function, any value of x is allowable, because any real number can be squared. Therefore, the domain of this function is the set of all x's, such that x is any real number. Since any number squared must be 0, or some positive number, subtracting 4 will result in numbers that are no smaller than -4. Therefore, the range for this function is the set of all y's, such that y is greater than or equal to -4. The graph of this function is a parabola. If we solve our function for x, we find that x can be either positive or negative. The right half of the parabola is comprised of points that have positive x values. The left half of the parabola is comprised of points with negative x values. If we eliminate the left half of our parabola and consider only the points which occur when x is greater than. Now that we have restricted the domain of our new function to positive x values, we can eliminate the minus sign from our solution. If we switch the x and y, the inverse function is formed. Since we can only take the square root of values that are 0 or positive, only values of x that are greater than or equal to -4 can be used. Therefore, the domain of the inverse function is the set of all x's, such that x is greater than or equal to -4. Since y is determined by taking the square root of some value, and square roots are always positive or 0, the resulting y values will always be positive, and therefore greater than or equal to 0. Notice how the domain of the original function is the range of the inverse function, and the range of the original function is the domain of the inverse function. Even though this example illustrates only one type of function, the processes and results are similar for all types of functions and their corresponding inverse functions.